Now, yesterday, what we have talked is we have talked about uh, operating system. So, what is an operating system and what is the usage of the operating system? So, here I talked about, let's say, any user use want to use the hardware. So what it has to do is it has to go for a very low level language so that the hardware can understood. But it is very painful job for the user to write the code so that the hardware can understand and give the response. So to overcome this particular problem, the operating system concept comes into the picture, where this operating system acts as a interface between user and hardware. So if user want to use the hardware or want to get results from the hardware, uh, it will not directly request to the hardware. It will request through the uh, operating system. So user will request to the operating system. Operating system will convert the request to the level of hardware, and it will instruct the hardware to do the task. And the result will be back to the operating system, and from the operating system, the result will be given to the user. So this is how your operating system actually useful here. One more thing is there is that this operating system work as a platform also. Platform means if a user are doing anything, and let's say it want to compile any program, it want to run any program, so operating system work as a platform to do that. Okay. So we have seen yesterday, like operating system is an interface between user and the hardware. With this diagram, I have shown you that how it is. After that, we have gone through the goal of the operating system. So we have find it out two goals. So one is the primary goal and another is the secondary goal. So as we can understand with this particular example is primary goal is convenience. How conveniently we can use the hardware, or how conveniently a user will interact with the hardware. This is the primary concern for implementing the operating system. And in the old operating system, which is called DOS-based operating system, where you have the command prompt and you have to write the command for any operation. So for that, this is not a convenient way. Although it is able to interact with the hardware, but it is not a convenient way of interacting with the hardware. So DOS operating system is not that much popular, and after that, we got many operating systems like Mac OS, which is from Apple. Then we have Windows OS from Microsoft. The problem related to the security will be solved in the Unix OS kernel. It is developed by a white hat hacker. Means that there is a category of hacker. One of the hacker is called white hat. They are ethical hackers. They are just like security personnel to the company. So they will find out by hacking it, and they will rectify it. Okay. But what black hat hacker can do is it will harm the system through the viruses, through the trojans, through hacking. So one of the white hat hackers, they have come up with the idea of creating a Unix kernel, and this is a secure kernel that we know. And now we have open source Linux operating system, where it is managed by the open community. And that is also so what are the goal of these operating systems? So the goal of all these operating systems are uh, to make the use by the user to the hardware more convenient. So conveniently and very easily, user can interact with the hardware. It can open the application. It can close the application. It can manage the application. It will run the program. So that convenience can be provided by the operating system. The secondary goal of any of the operating system is efficiency. That how efficiently we are using the resources of the hardware. How efficiently we are using the resources of the hardware. So after that, we have talked about the resources related to the hardware. So we have uh, resources is nothing but the hardware, right? Hardware of the computer. Okay. So in the hardware of the computer, we have CPU, which is a central processing unit, and then we have some IO devices. Then we have some main memory, right? In the IO devices, we have keyboard, we have mouse, we have console, which is your monitor. We have printer, right? We have secondary memory, which is magnetic disk. It is also a IO hardware, input output hardware, right? Where we can get the data into the system, and we can write the data from the system. So read and write operation can be performed in the magnetic disk. That's why it is in the IO category. And the CPU, what we do is we execute the processes, and these processes can be the OS level process or user level process. Okay, so for all those things, we'll see in the later on classes. But the main objective of the CPU is to execute the processes. This is how your a system look like. We have a CPU. CPU will interact with the main memory, and main memory will interact directly with the secondary memory. So whatever program or whatever process CPU need to execute will be should be there in the main memory. So you know the one of the scientists called von Neumann, right? Von Neumann has given the computer architecture, and based on that, it says that whatever program or whatever process or whatever instruction you want to execute, that instruction should be there in main memory. That is the architecture given by von Neumann. And the same architecture we are using here in today's world. You can see in today's scenario, either it is a laptop, or it is a server, or it is a supercomputer, or it is a phone. So any of the computer system or any of the computing device will have this same architecture. Means whatever program you want to run should be there in main memory, and from the main memory it will go to the CPU to run. Okay. And there are, of course, some peripherals, input output peripherals like keyboard and the monitor and the printer and the mouse. All those will come into the picture. So this is your computer system with the hardwares, right? So those are the resources actually. Now let's go to the responsibility of the operating system. What is the responsibility of the operating system? So mainly operating system has two responsibility. The first is all those resources should be allocated to the process generated by the user. Okay, so user will interact with the hardware through some instruction, like if it is clicking some button, or if it is closing some hyperlinks or opening some hyperlinks. So what will happen in the background? Some instruction is going to execute in the CPU, right? So those instruction need the resources. And what are the resources we have? We have memory is one of the resource, CPU is another resource, IO is another resource, files. Every operating system has file system. So how we are arranging those file, so that that executed file, how we'll allocate it, and how it will go to the main memory, and from the main memory how it will go to the CPU. So all these things are there. So your file is inside the your hard disk, right? Your secondary memory or your hard disk. I'll just write hard disk. Okay. So it is there in the hard disk. Your file is there in the hard disk. And so how will manage those files, or how will manage the hard drive or the magnetic disk, right? And the security concern. So responsibility of the operating system is to allocate the resources and manage those resources. So allocation and management of those resources will be done by OS. This is the responsibility of the operating system. Okay, let's go to different types of operating system. So yesterday we have seen different types of operating system. So one of the operating system is called batch operating system. Batch operating system was used previously in the early 80s and late 70s, when actually your computer system come into the existence. So how we can describe the batch processing? We can describe the batch processing with this particular diagram. Here we have CPU and some IO peripheral. So you can understand that these two are your resources, okay? And your memory is also there. So what you assume that all the jobs are there in the main memory. So assume that. So this is your main memory. So I'll just initiate. This is your main memory. This is your CPU. This is your IO. And what will happen in the batch operating system is individual will give their jobs, give their programs to execute in the CPU. And they will go and take a nap, take a rest, and they will again come up and see whether their job has been done and the result has been given or not. So previously, with the punching cards and all, they will put the jobs into the CPU, and from there only they will get the result. So the jobs will be given to the CPU. So definitely J1 is coming at very fast. So the job 1 will go to the CPU, and then CPU will execute this particular program or the job. And in between, if the job is required some IO devices, so the CPU will give control to the IO device. And in the CPU, there will be no J1 or there will be no program at all. But the CPU will not going to take J2 or the job 2. Why? Because it is a batch operating system. It will execute only one program at a time. And if a program is requiring the IO, so it will go to the IO. So the operating system will handle one job at a time, either in the IO or in the CPU. Okay, so that's why this particular is not an interactive operating system, where even though CPU is free, we cannot allocate another job. So waiting time of the job is more here in the batch operating system. Let's go to the second operating system, which is called multi-programming operating system. So what is the multi-programming operating system here is, the multi-programming operating system is an enhancement of the batch operating system. So when the person has given the job, and this job is there resided in the main memory. So I'll just draw the main memory. So it is in the main memory, and the job 1 will be executed in the CPU, because it is a first come first serve, right? So job 1 has come first, so CPU will be given to job 1. And if job 1 required any IO, so it will go to the IO. Once the CPU is free, CPU will take the next job from the job pool, and it will execute it. So it is just like a multi-programming operating system where multiple program will be handled by the operating system. Getting it? So multiple program could be handled by the operating system, not the CPU. CPU is a resource, IO is a resource, RAM is a resource. Multiple job could be handled at once, at simultaneously in the multi-programming operating system. And it will be handled by the operating system itself. Now, the third type of operating system is called multitasking operating system. So when the job will be submitted for the execution, so definitely it should be in a RAM or in the main memory. So these jobs will be executed in CPU. And what happens in a multitasking operating system is will not execute the job up to its burst time. Burst time is the time taken for any program to execute. Let's say we have a program will take, let's say, 10 milliseconds. Another program which is taking 20 milliseconds. Another program which is taking 6 milliseconds. So every program is associated with the burst time. But the CPU is not executing one program at a time fully. What it will do is it will preempt the program in after some time. Let's say if we are using the round robin fashion, so one job will get, let's say, 2 seconds, another job will, sorry, 2 microseconds, another will get another 2 microseconds, another will get 2 microseconds. In that way, what will happen is every job will be interacting with the CPU, and the CPU will interact with all the job in a round robin fashion. So in a multitasking operating system, we are entertaining, it is a multi-programming type of thing, but it is also an interactive operating system. Okay. So here the waiting time will be decreased in a multitasking operating system. And in today's operating system, whatever operating system we use is a multitasking operating system, where we can open different file at a time and different program at a time, and we can run all those programs at once. Now, the next type of operating system is called multi-processing operating system. Okay, so this is an example of multi-processing operating system. Okay, I'm not going to write it. I'll just write multi-processing here. MP, multi-processing operating system, where operating system could handle the hardware where we have more than one CPU available. Okay, more than one CPU means in today's computing world, we do not see only one CPU, one core CPU. We see either dual core or a 4 core or octa core, that is 8 core, 16 core, 32 core, 64 core, in that way. So if we have multiple processes available, so definitely these job, whatever we put into the RAM will be allocated the resources, because the resources is available. And these resources is again work as a multitasking. Means if there is a processor 1 and given the job J1, so J1 will have 2 seconds, and after that J5 is there, so J5 will get 2 seconds. So in that way, you understand that these type of systems are very fast, or these type of operating system are very fast. Very fast. How we can say very fast is every program that we run or every application that we open or that we use in our system will get the CPU, so that we understood that every program is getting the CPU and they are executing. So no program is going to take much time for execution. So this is called multi-processor or multi-processing operating system. Okay. The last operating system is called a real-time operating system. So real-time operating system is based on its what we can say, it's a time deadline. So every job or every process or every program is associated with the deadline, or with the you can say there is a deadline for executing that particular program. So if program is submitted to the CPU, so in the RAM only will arrange the job based on their priority. Based on their priority means which is required right now, means whose deadline is nearer, that particular program will execute that particular job. If a job is executing after its deadline, so it is of no use. Just like your missile systems, or just like your rocket, or if you have a space shuttle, so all these systems need to run in the real-time operating system. So if an event has to be triggered in this particular system, it has to trigger within the deadline. If it is triggering after the deadline, so it is of no use. So in the real-time operating system, every process is associated with the deadline. So all jobs, process, task is associated with some deadlines in the real-time operating system, and that deadline is associated with the process. So once it is given to the RAM for the process, in the RAM, it will be decided like which particular job will go next. And that type of operating system is called real-time operating system. Actually, we do not use real-time operating system, but yes, I told you in some of the systems like missile systems, or some of the system which required to be precise on time, those type of system actually require real-time operating system.